Hi everybody, sorry I couldn't be with you today, but we're still going to be learning geometry. So today we're going to talk about corresponding parts of similar triangles. Now yesterday we learned about angle-angle similarity, which was our way of proving two triangles were similar. Today what we're going to do is we're going to extend our proof and we're going to be proving how the corresponding parts of similar triangles are similar, which is very close to doing CP/CTC with our congruency proofs. So in your note packet, the first theorem we're going to talk about is the corresponding parts of similar triangles theorem. It states if two triangles are similar, then the ratio of any two corresponding segments equals the ratio of any two corresponding sides proportionally. Okay, what that means is if you have two corresponding segments. Now what I mean by segments could be altitudes, it could be angle bisectors, it could be medians, and it could be sides. If you have the ratio of any two of these segments, it should equal the ratio of any two other corresponding sides proportionally, which means I can set up a proportion with the altitudes to the sides or the angle bisectors to the sides. Let's look at some examples below. In example 1, we're given that triangle ABC is similar to triangle GHI. We need to find x, which is the altitude of triangle GHI. So looking here, what we have is we have the altitude of triangle ABC, and the altitude here is 9. And we don't know the altitude of our little triangle, that is x. So if we wanted to set up the ratio of the altitudes, it would be a 9 over x ratio, comparing triangle ABC to triangle GHI. Well, that's saying that we can set equal the ratio of its corresponding sides going again in the same direction from triangle ABC to triangle GHI. So we can set up the ratio of their sides by a 15/10 comparison. So again, we went from triangle ABC to triangle GHI, and our first ratio compared their altitudes, and the second ratio compared their sides. So 9 over x is equal to 15/10. To solve these, again, you just cross multiply, just like we've been doing in class. So here we get 15x is equal to 90, and x will be 6. So now let's look at example number 2 for another proportion. Example 2 says, given triangle KLS, and I know some of these letters you can't quite read, KLS, is similar to triangle MPJ. Find x, which is the length of AL. Now A is going to be on line KS, and AL is this line here. So it's saying find that length if we're going to call that x. Now P, across from P, let's put the letter B there. The length of BP is 16. Now, if you can see from the picture, those are angle bisectors. So we can compare the lengths of AL and BP and set that equal to the lengths of some similar sides. So looking at triangle KLS, the angle bisector length is x, and compared to the other triangle, which is 16. Now I have to compare the two sides proportionally, but in triangle KLS, I'm given two different sets of sides. So I have to figure out what side corresponds to side MP. And remember, the way in which we write the name of the triangle is always so important. MP should be related to side KL. So we want to use the 18 that's written there. That's an 18. So again, since we're going from triangle KLS to triangle MPJ, we already have the x over 16. I'm going to then set that equal to 18 over 24. Because again, 24, the MP goes with the KL. And now once I have this set up, I can just go ahead and cross multiply. When I cross multiply, I get 24x is equal to 288. Solve for x, and you get 12. Now example number 3 is going to be about a median. So looking at the triangles below, given that triangle HTA is similar to triangle CDL, let's find x, which is the median of triangle CDL. So some of these numbers, in case you can't read them, this line here, okay, that's our median line, and that's an x. And this number here for OL, that's 1.5. The median TE here is 3.2. And this line segment here, EA, is 2.4. So let's do our proportion. We're going to go from triangles. We can go from triangle HTA to triangle CDL. And again, I'm just going in that direction because of how the similarity statement is. So I'm going to do 3.2, which is my median of triangle HTA, over x, and set that equal to 2.4, which is the side of triangle HTA, in comparison to the side in CDL, 1.5. So go ahead and cross multiply. Here we get 2.4x is equal to 4.8. Divide by 2.4, and x is 2. All right, let's move on, and we're going to actually do some proofs with this. So going on to example number 4 on the next page, it says corresponding sides of similar triangles are proportional. We will eventually be able to abbreviate this as csstp, which again stands for the corresponding sides of similar triangles are proportional. So the sides of similar triangles can be written in proportion to each other. Sides are not congruent like they are with CPCTC. Sides are proportional. Triangles are similar, sides are proportional. So in this example here, what it's telling you is the first thing you always have to do in your proof is first prove that the triangles are similar. Once you have the sides are similar, then you can set up a proportion with their sides. That will be the next step after you've proven the triangles are similar. You could do something like side AB over side BC, saying that those two sides are proportional to the sides DE over EF. And then after you know that the two sides are proportional, or which sides are proportional, we can then take it one step further by cross multiplying. And if you cross multiply, you can see here we're going to get AB times EF is equal to BC times DE. So again, from yesterday, first you have to prove that the triangles are similar. Once we prove the triangles are similar, we can then say that the sides are proportional, and we can set up that proportion. Remember, a proportion is a fraction equal to a fraction. And then once you have your proportion, you can even take it another step further by cross multiplying. Now looking at the example below in number 4, you don't have to take it that third step. You can stop after you prove that the sides are proportional. But from this, we have to figure out what two triangles do we need to prove are similar. So looking at the proof statement first, I want to figure out what two triangles do I need to prove are similar first before I can prove my last step, which says that the sides are proportional. So looking at the sides, I have DC over BC. So those two sides are in a proportion with DE and BA. So I can see that the triangles I first need to prove are similar are going to be triangles CDE, similar to triangle CBA. So again, that will be my first step, and then my second step will then be able to say that the sides are proportional. Now remember, the way we prove triangles are similar is our angle-angle similarity theorem. So let's go ahead and start our proof. We need to go ahead and tee it off first. Write our statements and reasons. And go ahead and write down your givens. Your givens, we're told that we have line AE. We have a line DB. So both of those are straight lines. And we know that side AB is parallel to side DE. If you know two sides are parallel, you might want to highlight them. AB is parallel to DE. Parallel lines give us lots of angles that are congruent. One type of angles that we can prove are congruent are going to be our alternate interior angles. So find that Z. So you can make your Z, and you can either do angle D is congruent to angle B. Angle D is congruent to angle B if you draw your Z that way. Or if you draw your Z the other way, you could also do, my Z was drawn this way, we could have done angle E with angle A. Angle E would also be congruent to angle A for the same reason. Knowing you have parallel lines implies that the alternate interior angles are congruent. We now have two angles are congruent. We can say our triangles are similar. However, if you only proved one of those alternate interior angles, you might have also needed that angle DCE was congruent to angle BCA using vertical angles are congruent. Again, you only need to prove two angles are congruent, so any two of these three need to be in your proof. Once you prove the two triangles are similar, we're going to write that down. Triangle CDE is now similar to triangle CBA using the method angle-angle similarity. I can now state, just like we did with CPCTC, one step after my triangles are similar says that once you know the triangles are similar, the sides are in a proportion. So side DC over BC can be set equal to DE over BA. And your reason, corresponding sides of similar triangles are proportional. So it's saying the sides of similar triangles can be set in a proportion. And now we're done. Let's move on to another proof. So example number 5. Example number 5 says, given triangle ACB, which is the big triangle, if that triangle has a right angle, and you know CD is perpendicular to AB, can you prove that side AC times BD is equal to CD times BC? Well, looking here, this is different than the example we just did, because now it's saying that we're multiplying the two segments together, which means what we must have had right before this was a proportion. So we must have had a fraction set equal to a fraction and have been able to cross multiply. Well, two things that are across from each other were AC and BD, because when you go to cross multiply them, your result would have been AC times BD, which means that the other two also have to be across from one another. So CD and BC also have to be across from one another in order for you to be able to cross multiply and get that result. So looking at their proportions, I can see that I would have triangle ABC, and for this one I'd be proving triangle BCD. So remember, the first thing we have to do is first prove the triangles are similar. That's step 1. Once you know the triangles are similar, you can set their sides in a proportion. That's what we can do next. And then the last thing we can do from that proportion is cross multiply and multiply the segments together, which will be our final step, our proof step. So let's go ahead and start our proof. And again, our goal is to prove triangle ABC is similar to BCD first. So statements and reasons after you tee it off. And your given information. Angle ACB is a right angle. CD is perpendicular to AB. As our two pieces of given information. So again, looking at the two triangles we're trying to prove are similar, it's ABC, which is the big triangle, with the small triangle BCD. BCD. And again, sometimes it's helpful to either color code it or redrawing it sometimes is helpful too. So if you wanted to redraw your pictures off to the side, you can prove ACB and BCD. So we already have a right angle in ACB. Is there a way we can get a right angle in BCD? Well, knowing we have perpendicular here, that CD is perpendicular to AB, remember that perpendicular lines imply right angles. If CD is in fact perpendicular to AB, we can see from our big picture that we would have a pair of right angles. And the right angle that would be most important to us is this right angle here at CDB, because that's part of the triangle we're trying to prove is similar. So I can say in my next step that angle CDB is a right angle, and the reason is perpendicular lines imply right angles. Well, now that I have these two right angles, we can say angle ACB is in fact congruent to angle CDB because all right angles are congruent. So now we have one pair of angles congruent. We still need another pair. So here's where we have to look for overlapping angles. And the overlapping angles is easier to see in the big picture. I can see that the red and the blue overlap at angle B. So this angle B here is overlapping and is congruent to itself. So we can say in step number 5 that angle B is congruent to itself, angle B, using the reflexive property. Once you have two angles congruent, we can go ahead and say the triangles are similar. So we can say triangle ABC is in fact similar to triangle BCD using that angle-angle similarity theorem. Now that the triangles are similar, you can take it one step further and say we have some sides that are proportional. And again, looking back at the top, we figured out what the proportion was by undoing that cross multiply. So I can say that AC over BC is equal to CD over BD, for the reason that the corresponding sides of similar triangles are proportional. Once I know which sides are proportional, I can then end this by cross multiplying and getting that prove step. AC times BD is equal to CD times BC once I cross multiply. And that ends our proof. You always know at which point you're going to end by looking at the prove statement. So in some cases you can end at just setting the triangles, setting the sides proportional to each other, and at some cases you have to actually cross multiply. So please try example number 6, and you can check with a neighbor to see if you're getting the answers correct. And your homework this evening is going to be pages 9 and 10. Again, that's homework will be pages 9 and 10. Please refer back to this video. I will post this on my website if you have any trouble or want to just watch it again to help you do some of the homework problems. And weekly review number 25 will be being passed out to you, and that is due next Friday. So I'll see you on Monday.